thanks for coming. I realise it's a tough time slot and there's a lot of material to get through, so I'm going to move pretty quick. I run an independent computer forensic team in Sydney, creatively called Klein & Co. And my background sort of started off in IT audit and then into IT security and response and investigations. I worked for the AFP for a while and then worked in a big commercial forensic team and then set up an independent team about 2 years ago. And by independent, I sort of mean that we do things a bit differently and we have the time and the interest to explore new things, this being one of them. The team investigates a wide range of cases. We do criminal work, a lot of corporate litigation, a lot of expert evidence when there's some sort of electronic evidence in a legal process and we need to come in and analyse it and give opinion. We also do things like e-discovery and a lot of system intrusion cases as well. We also use a very wide range of computer forensic tools. So we use some very large enterprise tools that run on sort of multi-node, massive memory kind of infrastructure. We've got all the standard tools, Encase, FTK, X-Ways, Nuix. And we also use a whole bunch of open source tools and stuff that we develop ourselves. So there's a very, very, very big list of tools in our little tool chest. So that's the brief info. Quick plug, we are sort of looking for people. So if you know of anyone that wants to join a cool team based in Sydney, give me a yell. Now that that's done. Today, we are going to be talking about time travelling. And by that, I mean investigating events that have occurred on computers by looking at temporal data, i.e. analysing timestamps. Now, people have been doing this, analysing timestamps, for as long as timestamps have existed. Brian Carrier wrote some early tools in the area, particularly FLS and MacTime, which was as part of the Sleuth Kit collection of tools that he released. And that was largely based on some earlier work from Dan Farmer and Wietse Venema as well in a thing called the Coroner's Toolkit. And Wietse Venema also wrote IP tables, you might know, so he's quite a busy guy. Now, what FLS allows you to do is it allows you to get file system timestamps. And here's an example of that. So we have one file. So what we're looking at here is one file. It's in the recycle bin. It has the extension docx. It's been identified as a deleted file. And there's 4 timestamps, so NTFS file system, 4 timestamps, modified, created, accessed, and metadata change. And you can see this time entry here records that for that file, there was a modification to the file. At this time, we've got 2 timestamps, so it's put them into one, access and B. B is referred to as birth, otherwise known as creation time. And at this point, so 20 or so minutes later, we've got the creation time of the file on the file system. Now, timeline analysis can be quite complicated. There are a lot of rules for reviewing these entries, for interpreting what they mean. And what we're looking at here, or some of the bits of information that we can pull out of this, is the file that we're talking about was last modified at this time. So its data contents was modified at that point. That could be on this computer or more likely on a previous volume. I say a previous volume because the creation time is past the modified time. So it was modified somewhere and then a copy of it was created on this volume at that time. Now, at this time, not that time. Now, what's happened here is the metadata has been changed. Given the file is deleted, and we can also see from the recycle bin location, most likely that this is the time of deletion. So I've got file being modified at some point, put onto the volume, deleted, right? Pretty interesting, and some good information there. However, it's somewhat limited because it doesn't provide some of the more contextual information that is really valuable when doing timeline analysis. And Brad mentioned it this morning. Anyone who was lucky enough to be in the talked about context. Context is really critical in computer forensic investigations, and in fact, a lot of the time when you're looking at the high-level legal issues or the things that you're trying to prove, people don't care as much about, here's the timestamp on the email. They want to know what's the context of this timestamp. Why does it exist like that? What was happening? What does it mean? And they're the kinds of questions that we try to answer. So it would be great if we could get more information about this file, such as where did it come from? When was it first created? What was the original computer on which it was created? Who might have done that? How did it get to this volume? Who put it there? And in general, what else was happening on the computer while this happened? And that's what some of the more recent timeline analysis aims to do. So in 2009, a chap called Christian Gudjonsson, and I hope I've pronounced that right, in consultation with Rob Lee from SANS Institute. Rob runs the forensics, computer forensics stream at SANS. They got together and they talked about what Christian could do for his SANS Gold paper in forensics. And they came up with the idea of writing a tool that would extend timeline analysis capabilities. And Christian, being a bit of a skilled programmer as well, developed that, and he developed his tool called Log to Timeline. I'm going to be showing you what that does a little later. Their concept was, within a computer system, as well as the file system, there's a whole range of places where timestamps are recorded. So link files have timestamps within them for the target documents. Index.dat files, which record internet history and file access, will show you those kinds of timestamps as well. The registry is full of timestamps, in addition to all the other valuable info the registry contains. System logs obviously contain timestamps. Then there's things like volume, shadow copies, and system restore points, all of which contain files that have timestamps. So the notion was, rather than limiting our timeline analysis to simply the file system and the obvious timestamps there, why don't we grab all the information we can from all these other places, put them all together, develop a chronology, and be able to sort of step back and see what was happening on a computer at certain points in time. And that's what Christian developed in Log to Timeline. So expanding on this example, what if you could do this? So you can see the black entries here are the original file system metadata that we have and timestamps. And now we've expanded it to include the entries in red. So we can see EXIF information out of the doc file, shows us when it was created, shows us the user. Index.data entries on the computer might show when a different user accessed the file, and it'll also show us, for example, the network location from which they accessed it. The registry might show us that after they accessed the file there, they executed Microsoft Word, and at the same time as executing Word, they opened up the file. This time we're opening it from a local drive. And then we've got the deleted file here. So you can already see, just adding a few bits of information to this timeline, a lot more context, a lot more answers about what was happening with this file that helps to answer those questions that we talked about before. Okay, so Christian designed and built Log to Timeline in a very modular way. The idea being, given the vast amount of input files, you want to have different modules that will allow you to go out and analyze those files. These are all the modules that Log to Timeline currently supports, therefore all the places where it can extract timestamp information from. And it was written on a Mac, for those Mac lovers. So really, it's thanks to sort of these trailblazers, these developers, that we can now do this advanced analysis that I'm going to talk about today. However, the problem we now have is we have almost information overload. If you take a timeline from a typical computer system, it's fairly easy to create millions of records worth of timestamp information. And the natural question is, what do you do with this all? How do you analyze it? How do you make sense of it in a quick and efficient, sort of powerful way? Now, if you ever ask me what my favorite forensic tools are, one that will always appear on the list is Microsoft Excel, because there are just so many situations in forensics when you're collecting information and you want to dump it into Excel and you want to manipulate it. And that's kind of the natural choice for people that do this. But when I first got introduced to timelines, when I took Rob Lee's SANS 508 course, which I highly recommend if anyone wants to do it, I thought, there's got to be a better way, and I started exploring these things, and I was chatting with a colleague who said, have a look at Splunk. So I started having a look at it, and sure enough, after a bit of testing and playing, it's a very, very powerful way of reviewing and analysing timelines, and that's going to be the basis of sort of the guts of what we're going to talk about today. So let's do a bit of time travelling. These are the tools we're going to be using. FLS, for extracting file system metadata, which comes from Brian Carrier's Sleuth Kit. Log to Timeline, which is the tool that Christian developed. MacTime, which is also one of Brian's tools from Sleuth Kit. And the tool to analyse them all will be Splunk. Now, installation of those things is really, really simple. I should point out that there's a blog that I've just put up on our website, and it's got detailed instructions on how to download them, how to install them. There's some customizations you need to make for Splunk, which I've got in config files that you can just download and whack into the directories, and it will take you about 10 minutes or 5 or 10 minutes to set these things up. It's really quite straightforward. And in fact, where you can get them from is these places. I had to put Splunk's motto up there because I just thought it was very cool. Rob Lee from SANS has also developed a Linux distro called Sift Workstation, which I recommend you go out and check because it's got pre-built versions of all of these. You can boot it up in a VM and you can start using it for analysis straight away. So he's taken all the pain out of downloading all the dependencies and things, not that there isn't much. And there's a lot more forensic tools in that distro as well. So very, very happy to give that a plug. So let's start. Now, I'm not going to actually be doing these commands. I'm just going to go over these briefly because I want to focus more on the analysis part a bit later on. The first step is to extract our file system metadata using FLS. And now we're going to point FLS at a block device. So you've got your raw DD image, or you could just point it straight at the block device, dev, SDB, whatever. The options I've used here, obviously, man FLS is your friend for figuring out what they mean. But the options I would use, M will specify to produce your output in what's called a MacTime format. MacTime is a particular format that's used by timelining tools. It has the option to append a string to the start of every entry so that when you're analysing it, say, in Excel, you know where this timestamp came from. I leave that blank because when we import it into Splunk, one of the steps we're going to take is to give it a host name. So just leave it blank for now. O is our sector offset to the start of the file system within the image. Obviously, if you're pointing at add a partition like dev SDB2, then you don't need to specify the offset. R will recurse FLS through the file system. That's our raw image that we're going to use, or we can use a device. And FLS body is simply the output file. You'll see this body is just an arbitrary extension, but again, it makes it easy to identify that what you're outputting is what's called a body file in MacTime speak. So you run that against your file system. It can take a matter of seconds, and your output is going to be a massive file that has lots and lots of lines that look like that. Cool. Does that make sense to anyone? Not to me. So what we're going to do is we're going to convert this into a CSV so that we can then dump it into Splunk, and we're going to use MacTime to do that. There's the command. Here's the options. Pretty straightforward. We tell MacTime to take that body file that we just created, output into CSV, give it a name. Fairly straightforward. And the result will look something like that, a file that looks like that. So you can see how, so it's a bit low down for some of the people there. You can see how it's starting to make a bit more sense. We've got a timestamp. We've got, that'll be a size. We'll have type. We'll have directory or file location. We'll have GID, SID, MFT details, and the file name. I'll come back to that later. Okay, the next step is to extract other temporal data, i.e. timestamps, from other artifacts on the drive using using log to timeline. So where FLS points at a device, log to timeline points at a mounted file system, and it just traverses through the file system itself. And what it actually does is it looks for files using magic numbers and other means, and it tries to identify the type of file, and then if you've specified to parse it with a certain input parser, it will do that. So -F is the switch that will tell you what input module or parser to use. I've just selected 3, and you can pretty much tell what they're going to look at: EXIF data from within documents, PDF metadata, and master file table information. That list I had before that had all the different modules, you can specify each of them individually, you can chop and choose, or some of them being grouped together. So for example, there's a WinXP group, and you can just specify that, and it'll just pre-select a whole bunch of input modules for analysing WinXP box. -O, we've got our output in MacTime format. Again, we're recursing through the directories. We're writing the output to timeline.body, and we're pointing it to the mounted volume. All this is on our site too, so you don't have to sort of busily take notes. You can just download it after. And then what you would do is you've obviously had your log to timeline body file, which is going to be in that sort of complicated format that we saw before. Run it through MacTime, get your CSV. So what you've now got is 2 CSV files that contain all your file system metadata and all your other temporal metadata that you've got using log to timeline. Now, quick side note. All of these tools allow you to specify time zones and specify the time zone in which the computer resided. If you don't specify a time zone, it'll default to the local time of your examination machine. I've had various situations where time zones, I've specified local time or specified a time zone, and when I've inspected the timelines, there's mismatches. So there are certain timestamps that you think should be in local time that are GMT. There are some that have dropped back twice, so they're sort of 22 hours behind instead of 11 and other things. So what I would say to you is I recommend you test your build on known evidence first. So once you've got your tools installed, get a USB key or a computer or a drive and run some of your modules and just make sure the timestamps are all working fine. Okay, so the next step is we're going to put these into Splunk and start playing around with it, but there's one more step. Before we do that, these files will each have a header which will look like that. In order to what I've done is the customizations that I got for Splunk simply make them all lowercase because I'm lazy, and it's easier when you're doing lots of searches not to capitalize your searches. And they also make the file name just file, so it's a really small tweak. Pull out your favorite text editor, and away you go. Okay. So now we have our timestamp info, our CSVs, and we're ready to put them into Splunk. Now I've got a demo case rigged up. And the situation is this, which is not an uncommon situation at all. Someone comes to us, a chairman, managing director, whoever in a company, very senior, and says, I run a big international company, and I've had a bit of an issue emerge today. One of my senior employees has left, and I'm very suspicious about what he was doing before he left, and I want you to help me analyze whether he might have accessed or taken or done anything with any confidential information. This is very, very common. We probably get one of these every week or two. So at this point, I'm going to switch out of here and actually jump into Splunk. Now I will need to let me just go to the home thing. Can we see it? Hey, and it works. Okay, so you install Splunk. It's got its local web server, and I won't go into all the architecture and stuff behind it because it's all very well documented, and you can look at it on the site. I'm also going to, if you don't mind, skip over the bit about importing data because, again, it's just a few simple steps and you can follow the instructions on the website. I'd rather sort of focus on what you can do with it in this session. It is important, though, to remember Splunk has this notion of indexes. So it will have different indexes in which it stores its data. Now, in forensics, one of the things you always want to do is you separate your data between cases. And so rather than just letting Splunk dump everything into its main index, which is called main, we would create a new index for every case. And we would put all of the timeline data for a case into that index. So I've already done that. The next thing you would do is obviously launch a search. So let's do one. Now let me do a very simple search to give you an idea of what's happening here. I'll specify my index. And away we go. So, and all I've done up here, those who are familiar with SQL queries and the like will be very familiar with this. All I've done is specified my index, and Splunk is going to go and get me everything that is in that index, which in this case is going to be, well, everything, because I haven't specified any other filters. What it's doing here is it's creating, as it goes, this timeline of activity. It's interesting the way it works. It sort of goes backwards and then sort of goes backwards in time as it goes over its events. It's telling me, because it's running on my little Mac, that it's a little bit slow. And as the event count is increasing, you can see that here. As it goes through the events, it's graphing them there. All pretty cool. I'll let that finish just so we can see how many events are here. While it's going, I'll just point out a few things on the screen. Can you see the rodent? There we go. Excellent. Down here, you'll see the actual entries. Now, they don't look very nice, so we'll just drop it into a grid view here. Ah, look, much nicer. So now you can start seeing some of the metadata that we've pulled out of our timeline. We've got a timestamp, we've got the host, which when I added it to the computer, to Splunk, I called it Scott PC. We've got the the type of data, and this relates back to those file system timestamp types that we had before. Mode, particularly useful for the first character, R for regular file, D for directory. Metadata address, so inode or MFT, file size, and this information here. Now, there's two kinds of data, remembering the two files that we've got, there's two kinds of data that we've got in Splunk. One is file system information, which is this kind of stuff where all these fields make sense. The other is our log to timeline data, which is all that other temporal data that we got from other sources. That's denoted by a few things, the main one being these square brackets at the start of every entry, which actually shows you the log to timeline module that was used to get this bit of data out. Okay. God, our search is still going. That's actually quite slow. There's about 1.5 million records in this index. There you go, just finished. So even on a dinky little computer, you get pretty good speeds. On a fast box, it's almost instant. So the first thing you'll notice is over here, this is our timeline, and this group here is 2011. So why, you may ask, do we have entries all the way down here and all the way out there? It's quite common in timeline analysis to get these big outliers. So you tend to get a lot of files or metadata which is stamped with epoch time, so 1st Jan 1970, and you get ones further down the line as well. You also tend to find timestamps, and these are just anomalies that have a date of 14th of February 2039 kind of thing. So they're right up the end. So let's just restrict this to 2011. Pretty quick and easy, and as you can see, it's going to crunch through the data pretty fast. And you can see pretty quickly the kind of activity that we're seeing on the system. So there's a few other things you can do. I should point out, this field here, _time, is Splunk's default time field. So this is what it stamps every event. Everything else is a text field. So in terms of what kind of searches you can do, it's really only limited by the creativity of how you want to analyze those text fields. So for example, if you say, let's look for example, at every directory on the system, we might say mode equals D star. And what this is doing is pulling out every single directory by simply limiting it on the mode identifier. You might say, okay, well that's very good, but I want to sort by say the file, by the file name, so the directory name. So we can do this, quick search. This is sort of a way of browsing a file system using a timeline. So this will sort it based on the file attribute there. You can reverse it pretty easily, and it'll just flip the whole thing around. So now let's get back to our case. Scott's left our company. We know he did it this week. So we're particularly interested in his activity in November. So let's limit our search to that just for now. Now, I've created another index, just called Ruxcon Nov, and that's going to show us activity in November on this computer. So we'll let this run for a couple of seconds. There's not too much in it. There we go. So you can see most of the activity in November. We've got a bunch of activity over here on the 17th. We've got some on the 14th, sort of 10 and 11, and we've got some earlier in the month. All right, so we're getting a bit of a pattern of what's going on. Now, how are we going to start looking for what Scott was doing on this computer? There's lots and lots of ways we can do it, which I'll go into. One of them is, as I said before, all of these attributes are simply text fields. So we can rely on the fact that the log to timeline modules down there always format output in a certain way. One of the places where they get data is the enter user hive, and within that the user assist key. So we're going to use that, and we're going to look for a string of text in there called time of launch, and we're also going to limit it to the user or to anything that involves Scott. And just for good measure, let's sort by time. And I'm just going to quickly get rid of that so I've got a bit more real estate on the screen. So pretty quickly you see we've narrowed this down to only a few entries. And what we're looking at here, these are all coming out of that user assist key from the registry. We're seeing Microsoft Internet Explorer launched there, run count 1. As it's executed subsequently, that run count will increase. We're seeing Windows Explorer executed there, and we're seeing Microsoft Word executed there. If I move over a bit. So already, pretty quickly, we know that the 3 programs that he would have executed... Oh, bugger. Sorry, I hate that with Safari when you swing over and it loses your page. Let me do that again. You must specify a field. Oh, yes, I must. It also assumes you can type, which is a problem sometimes. That. There we go. So that's where we were before. So pretty quickly, we've done a search. We've looked for everything that involves Scott in the metadata. We've looked for the string time of launch to get execution information about programs. And we've sorted it by time, and we can see what was going on. So we're starting to get a bit of picture of what's happened. Now we might say, all right, let's look at, say, access to some files, because our client, Dr. Evil, said he's particularly interested in access to files. So we know they do a lot of work in Excel. Let's just look for anything that has a metadata reference that involves Excel. Okay, nothing there. Let's change it. What about PDF? Aha. So now, and let me sort this as well. And this is taking metadata from various different places. So we have an interesting document right at the top of the list. Secret plan for the laser, which happens to be in users Scott documents. So now this is what is this? This is file system metadata that's showing us creation of that document in that location. Down here, we're seeing metadata pulled out of a PDF, and you can see the timestamp here matches the modified timestamp there. So these entries are corroborating the fact that this PDF file appears to have been created in this location, or at least last modified in this location at that time. We've got an Internet Explorer. I'm just going to move this over. We've got an Internet Explorer link that shows access to the file. We've got a recent docs link, which again shows opening the file, and we've got a couple of document shortcuts as well. So again, we're pulling information from various sources, putting it together, and very quickly getting an idea of what's going on this thing. So all right, we've got our PDF file. Now, let's just look at other file system activity or other file activity. You can see these Internet Explorer, these index.dat entries down here. If we use one of them and look for, say, anything that looks like that, so what we're relying upon here is Windows Explorer. When you open up Windows Explorer, browse to a directory, double-click on a file, and open it, you're looking for those entries that get created in the index.dat records for the user. So we filtered those index.dat entries, and we're looking for anything that has that file tag in it. And down here again, pretty quickly, you can see the results. So we've got these files. We've got the C users documents, secret plan for the laser.pdf. We've got another copy of it accessed from a location on the J drive, which we happen to know from the client is a network share, and it's from a directory called the Alan Parsons Project. And we also have this third link where we've got a file accessed from the Z drive, which is not part of the network at all. So the natural question is, okay, what's our Z drive? And also, you'll notice the extension is different now. So now we're looking at a docx extension. So I might say, okay, well, this Z drive is particularly suspicious. This is particularly nasty. We know that Scott's got a copy of it on his computer. We know that he accessed it from a network share. What's this Z drive? So let's find out. Let's just pick everything where the metadata has any reference to Z drive. Now what we're seeing is a few things of interest. This first one here comes from a recent docs key. So again, this is a registry key for the user Scott, and it is showing access to a folder. So you can see it's even described it for you. Scott, the user, recently opened a file of extension folder value Corsair. So now Z drive has a label, and Corsair might be familiar to some of you that have USB keys. We've got our Internet Explorer link showing access to the Z drive, and we've got a whole bunch of shortcut links as well. Now, one of the neat things about shortcuts is when you access a file when a shortcut is created, it captures within the shortcut information about the target file, including its file system timestamps and the serial numbers, volume serial numbers. And if we browse over to here, we've got a serial number for, and the link file also specifies it's a removable volume. So again, pretty quickly, we found that the file was accessed from a Z drive. We figured out what Z drive looks to be. We've got a serial number. We've got evidence that it's removable. And we've got evidence of files, or one file in particular, that was accessed from it. So, the secret plan. Let's see what we can find out about the secret plan document. Now, if we sort by time again. Actually, let me just restrict that as well. I'm going to use one of the inbuilt Splunk fields for date, which is date underscore M day, so day of the month. And I'm going to sort it by time. And now we're seeing some interesting information here. We're seeing that 11:24 and 18 seconds, we've got the link file created that shows access to the file. At 11:24:28, we've got creating the PDF version in Scott's documents. And then at 11:24:36, down here, or from here onwards, we've got the link file that shows the birth time of the docx version on the Z drive. So this is interesting because we don't have the USB drive at this point, but we've got a link file that shows access to a document on the Z drive. And again, as I said, the link file captures the birth time of the file on the USB key. So there's a lot we can tell about files on that key, even when we don't have it, simply by getting information out of the computer system. And then 11:27, we've got other versions or other artifacts showing access to the docx version of it. So you can see, again, we're pretty quickly building up a picture of what's going on this computer. I'll show you a couple more. Recycle bin. Recycle bin is identified through recycler or recycle bin information in the metadata. Let's have a look at descending order, because we want to get the most recent records first. Just let this finish. Oh, actually, I'll just take out this, because the recycle bin won't always be associated with Scott. And you can see here, we've got a couple of recycle bin records that might be worth looking into, the docx records there, and they might look familiar to you. Remember those very first FLS entries that we looked at before that showed when the document was last modified, when it was created on this volume, when it was deleted? So these are those records that we're pulling up there. So we know he's got the file, he's got it off a network drive, he's had it on his computer, he's had it on an external disk. The other question is, well, could he have emailed it? The other, if you think about the ways of sending data out of companies, they're sort of the main ones that we see. A neat way of finding internet activity, particularly log into online accounts. Now, I'm just going to restrict this a bit to the 17th of November, and we're going to look for anything that involves Scott and anything that involves the phrase login. And again, pretty quickly, you can see here we've got records coming out of Internet Explorer history, and it's showing us Scott accessing login.live.com, login.live.com, login.live.com. So we're getting a lot of activity there. So it looks like he may have a Hotmail account. One of the things you're always worried about when you have internet activity around these times would be, for example, someone sending an email out. One of the neat ways of finding that would be using a common string that a lot of email providers use on their URLs for attachments, which is attach. So now we're looking at any URL record that has the phrase attach in it. What's happened here? Sorry? Ah, yes. Now, that raised an interesting point, which I should have mentioned before. Each of these things that I'm adding to the search bar are treated as an AND operator. So what we're looking for here is file with login and file with attachment. Probably not going to happen together. You can specify OR by having, parentheses, something or something, like that. or you should do that. And here we've got attachment information. Now, if we were to, I won't do it now, but if you pull out wider information about internet activity and file system activity on this, you'd see the sequence of events. File being accessed from the network, activity on the file locally, Hotmail being logged into, Hotmail attachment being created, Hotmail logout, other file system activity, file gets deleted from local machine. And we've got all the USB information as well. So again, we're stepping back from the data and just sort of saying what's going on, and by sort of teasing it out in various ways, we're getting information about what's happening. So we know he's got a Hotmail account. The next question might be, okay, well, how do we get a subpoena on that Hotmail account? How do we even find what it is? Easy way of finding the address. Just look for it at hotmail.com. And if I were to move this over a bit, you can see about there. We have a Hotmail address. So, pretty easy, pretty straightforward. And you can see how, in very simple, quick, powerful terms, we've gone from having standard file system information, which gives us good information but not a lot of context, to a much more richer sort of environment for doing analysis and starting to tease out some of the contextual information about this. So let me jump back into my Prezzo. Yes, so we've done that little job. Moving right along. This is the Hotmail. So if you examine the computer and carve internet activity, if you can get it quickly enough, you might be able to recover the Hotmail. There's actually one thing I forgot to show you before. When we did that search for the attachment, and we had those URLs that showed that attachment activity on Hotmail, one of the entries, or the entry immediately after it, had a download of a file or a URL that contained a file called attachment.png. Now, and then that file was created in the local internet cache. So if you look at this, I'm not sure whether it's that one or that one, I think it's that, but it's the attachment.png file that gets downloaded and put into your local internet cache after you actually do the attachment. So if you were to test Hotmail and test that functionality and what artifacts it created locally, you could possibly use that as evidence to say, we've got the login to the Hotmail, we've got the attachment URLs, we've got the creation of the images that get created after the attachment gets completed successfully. Therefore, all of this, again, is building a picture that corroborates what we think is going on. And there's the docx document itself. So, now I'm going to talk briefly about the problems with time travel. And this is touching on some of the things that Bradley Schatz was talking about in his presentation earlier on today. This all looks kind of cool, and you think, oh, great, the answers are all in front of me. But as with all forensics, you have to think about what is it that you're actually looking at. Where does it come from? What does it mean? Those file system timestamps we showed before, there's a whole sort of art form, I suppose, and a set of rules for looking at them. If you do the SANS course, and these are slides that Rob Lee kindly let me use from the SANS curriculum, the MAC times, I won't go through these in detail, but MAC times mean different things on different file systems. So ext23, for example, will not have a created time over there. FAT will store its time in local time, so regardless of GMT offset, but it won't store, or rather the access time will have a granularity, as you can see there, of 1 day. Now what that means is if you're looking at an access time on a FAT disk, FAT file system, so a USB key for example, depending on the tool that you use, it will display the access time in different ways. Some tools will actually just show you the access time as midnight. And I've seen reports where forensic examiners have provided reports and said, this file was accessed at midnight on this day. And you go, okay. Whenever you see something that's too perfect, like 12.00.00, it always raises questions. The user happened to have accessed it right on the stroke of midnight. Other tools can be even worse, where they will try to be clever and say, well, I'm going to adjust all of these timestamps on these files so that they make sense for you in your local time zone. So being in Sydney, we'll get the access time, which is midnight, and we'll just bump it forward 10 hours. So then the forensic report might read, user accessed the file at 10 a.m. .00000. So, and it goes back to, again, Brad's point about don't just trust your tools. You have to beware of what I call the CSI effect, which is seeing the findings and going, aha, that's what it is, that's the truth. You can't dispute it. You have to always be thinking about what's going on behind the scenes. You have to understand where timestamps come from and how they're stored. So things like this. I'll just show you these briefly. These are some of the time rules for analysing those various time entries. So for example, if you're looking at a Linux file system and you see a timestamp which shows a change to modified time, access time, and change time, what you're probably looking at is a file copy. If you're looking at a timestamp that shows you only change, but not access or modified, you're probably looking at a file move within the volume itself. And there are similar rules that apply to Windows, and this is just standard information, timestamps on Windows. So you can see that it's quite complicated when you actually look at each time entry and interpreting what it actually means. Here's some other time rules for Windows. Some of these will be logical. Creation date, so the date that a document is or a file is created on a particular volume, it will remain unchanged. If you move it, say, from a FAT system to a subdirectory or from an NTFS to another. The one that always interests me is it will remain unchanged if you move it from FAT to NTFS. You would think that doing the creation on a new volume would actually update it, but it will remain unchanged. So there's some little tricks and traps along the way as well. I'll put up some of these now. So as I said, you need to understand where time comes from and how it's stored. So index.dat records, Internet History, will store time differently to, say, document metadata or to file system metadata. And also, don't assume that all timestamps come from the computer itself. Just because you've got timestamp information from a computer that you've imaged, some of those timestamps could be stamped by other computers. So for example, the last modified time of a document, if that document came from somewhere else and was copied to here, the modification time should remain the same. So there might be a discrepancy between the accuracy of that and the accuracy of other timestamps on the computer. And they might include timestamps that have come from a range of other computers. So you need to keep your mind open to that. I've talked about granularity of time. You need to be careful about how granular time is recorded in different places. That access time or access day one is an important one on FAT file systems. The other thing is log to timeline and FLS will dump file system information, dump time information rather, by second. So you get a whole group of entries that all have exactly the same timestamp. They're not presented in the order in which they actually occur. They might have been sort of flipped around. So you need to be conscious of that. Just because an entry exists above the other one on your timeline doesn't mean it actually happened before. It could have happened, slightly after. So you need to think about, again, what's the sequence of events that's causing these timestamps to be the way they are. Operating systems will treat time differently. So, for example, Vista and Windows 7, you probably know, will not update the access time normally. However, that's not a blanket rule. If you modify a file, make changes to a file, it will update the access time. So it's incorrect to say it's Windows 7 or Vista, therefore no access time changes. Similarly, on a Unix file system, if it's mounted with the no at time, no a time attribute on the mount command, won't update the access time. So there are ways in which time will not get updated. There's also tools, sort of anti-forensic situations, things like timestamp or touch, that can obviously modify timestamps, although the ability for them to modify all file system timestamps may not be clear. So for example, an NTFS file, it will have its standard information timestamps. It's 4 timestamps that we looked at before, but there's also another set of 4 files in the file name attribute of the master file table. And some tools will be clever and modify timestamps in one set, but not be able to modify timestamps in the other. And that's one way of, for example, analysing for deliberate changes to timestamps on files. And the other point I should make is timelines are not a complete history. You can't pull up history for a certain day and say, this is what happened on the computer on that day, because obviously timestamps get updated. A last access time is a last access time, not every access time. You'd be surprised the number of people, the clients that come to us, and they ask you questions like, tell me every time this file was accessed. And you go, well, you can't really do that. There's ways in which we can look for it through index.dat records, shortcut files and other things, but there's no magic log that says this is every time the file was accessed. So we're not looking at a complete history with a timeline. We're just looking at those remnants or artifacts or those sort of digital breadcrumbs that might still exist. And of course, to top it all off, just when you thought this was all looking a bit shaky, all of this is based on the accuracy of computer clocks, which various studies will give you some interesting reading about. So, wrapping it all up, there's a good saying that I like to remember when I do analysis, which is if you set out to find something in particular, you're probably not going to find it. But if you set out to find anything, chances are you're going to find something. And what I mean by that is there's a lot of forensic analysis that's done by trying to find what it is that you think is going to be there. So, it's surprising when we get instructions, or not really, we get instructions from people saying, here's the computer and here's the keyword searches we want you to run. And we say, okay, what are you looking for? What do you think's occurred? What's actually going on? What findings do you want? What objectives are you trying to conclude? Don't look for the thing, don't just go looking for the thing that you think's there and trying to retrofit your analysis for that. Let the evidence sort of talk, and that's one of the reasons why timelines are so powerful. We're finding a bit of information, like we saw certain days of activity, certain files, certain directories and other things, and that helps us narrow in on particular things, but then we're sort of looking more widely and saying, well, what else was happening at that time, and analysing each timestamp entry to try to reconstruct that activity. Letting the evidence talk in that way is a very powerful way of doing the analysis. So that example I gave you before about when you attach the Hotmail attachment and it creates a little local file called attach.png, how many people would think, I certainly wouldn't have before I did this, how many people would think, he's sent something off Hotmail, I know how to search for that, I'm going to look for this particular file in an internet cache. You'd never think that. But by doing the other work, finding where it existed and then looking at the timeline data, you're not only finding the evidence you want, the attachment, but you're finding all this other evidence that corroborates what you're seeing. And again, the more you've got to corroborate your findings, the stronger you can present a theory, a hypothesis as to what you thought occurred. The other thing about timestamps is or timeline analysis, it lets you very quickly, as we've seen, identify particular things and do some very quick searches. Getting the timeline data, loading it into Splunk can take less than an hour, and you can be searching it straight away. The thing I like about it most, though, is particularly when you start this, you realise that this is not, despite the flashy interface that Splunk has, this is not point-and-click forensics. This is not, here's the button, here's the evidence I want, let's press a few buttons. You need to use your creativity to think of how to search for the evidence, and you need to also have a good underlying understanding of the data that you're looking at so that you know what to look for and you know all of the anomalies. And the thing I love about it is when you start doing it, it's overwhelming, the amount of information that you've got, and you find yourself seeing the activity that makes sense and then all this stuff that you just look at and go, what the hell is going on here? And it actually forces you to investigate it and to analyse it and to test it and to figure out what's going on. And that whole process, it's almost like you feel like you've gone to the gym. It was really hard work, but once you got through it, you feel so much better for it because you know that you've learnt so much, not only about your evidence in your case, but just about sort of forensic analysis in general. So anyone who wants to sort of develop and grow those skills, this is a fantastic way to do that. And that is it. As I said, there's details on our website, there's instructions, and there's the config files that you need for Splunk if you want to do the customizations. The whole thing will take you like 5 minutes to set up. Have a go. Any questions?
Questions?
Yes, sir.
Hang on, wait for the talking stick. There are 2 hands there.
One stick at a time.
One stick at a time, that's my motto.
Oh dear.
Number 1. What do you use for your court reporting? Is there something that comes out of Splunk that's nice and pretty, or do you end up producing registry report plus index.net plus?
It depends. I am not a fan of dumping lots of information into reports. I hate expert reports where they just go, I examine the computer and there's some stuff in the registry, refer attachment A for a registry dump, and you'll have 80 pages worth of just dumped registry. It's garbage. I always say the most important thing that we do, all these tricks and techniques and things are great, and that's sort of the means to the end. That's how we do what we do. But when it comes down to it, the most important thing we do is in forensics is we explain very technical things to people, usually in legal or for legal requirements, in very specific, concise terms. And an expert report that has a dump of information in it doesn't do that. You're better off, and this is, my reports will tend to have explanations and chronologies and discussions about the technical. And then if there's something in a registry entry or a timeline, I might say, here's a table that shows you those entries, and here's what each of them means. So there's also a psychological thing that goes with that. I'm a big believer that if someone understands the process you've gone through to reach an answer, they'll tend to agree with your answer. So if you can make it very, and I've seen this in court a number of times where people will be presented with a very, very, good in the sense of technical, detailed expert report, but it's presented so poorly that it'll last about 30 seconds and then they'll just, I don't understand a thing here. This doesn't make any sense to me. So the whole point of what we do in forensics, I think, in many ways is to do that understanding. So to answer your question in a very roundabout way, you can export stuff out of Splunk by just using output CSV, and it'll just dump your search result in a CSV, drop it into Excel, pretty it up, get rid of all the stuff that's going to confuse people and it's not relevant, whack it into your Word document. Away you go.
The other question was here.
Two questions. Yep.
Far out.
First question, Nick. Appropriate use policy. If the organisation doesn't have an appropriate use policy, the work that you actually do can still be presented in court.
Okay. In New South Wales, there's a thing called the Workplace Surveillance Act, which came out in 2005. It says if you're going to surveil the activities of people in your organisation, you need to tell them about it, and it tells you what you need to say to them. So it says things like whether the surveillance is ongoing or intermittent, what are you going to use it for, how are you going to do it, etc., etc., etc. Now, you need to have done that before you do the investigation, and it defines surveillance as input or output from a computer, which is basically everything. The punchline, however, is don't confuse a workplace surveillance notice with a acceptable use policy. We have a lot, and I should also say, caveat, I'm not a lawyer. This is not legal advice. We have a lot of clients that when they want us to investigate what's happening in their workplace, and we say, by the way, just want to make sure you've complied with the Workplace Surveillance Act, they say, that's fine, we've got an acceptable use policy. And you go, no. That says thou shalt not browse porn and other dirty stuff on our network. The Workplace Surveillance Act says a whole bunch of other things that need to be advised to your employees in order to do our work.
You've touched on the second part of the question with the 2005 Act. How does it actually deal with an organisation that's in multiple states?
In my experience, it hasn't been an issue for organisations outside of New South Wales. It's simply that. I mean, you're touching on areas that can get very complicated and legalistic, like, well, what happens if the staff are in New South Wales but the data is held somewhere else? What happens if the staff are travelling at the time or if they're staff of an organisation that's registered in New South Wales but they work in Perth? What happens to data that was collected before 2005, like a backup, that we want to use? So the data was collected before the law came into effect, but we're now using it. What part of that is surveillance? Is it the collection of the data or the analysis of the data?
Nick, mate, you seem to be asking questions rather than answering questions
Absolutely.
here.
That's why I say you ask 10 lawyers and you get 20 different opinions on this. These are all tricky legal issues that have come up, but it highlights how things like that they do come up in computer forensics. You need to be cognizant of them.
That's a very good question. Do we have any other questions? So that's pretty interesting. So, like, even if someone's doing something that's unacceptable under their use policy, you can fire them, but you can't say why because you didn't really have the right to be surveilling them in the first place.
Maybe. I'll give you a quick war story. I did a case where we got some email from an employee in an organisation, and one of the emails was very critical to a dispute he was having with his company, and because he was basically fired and he sued them for unfair dismissal. Now, when the case went to court, there were legal arguments about the use of that evidence, and as Brad was saying before, we don't have the same admissibility issues in Australia that they tend to have, say, in America with this whole sort of fruit of the poison tree notion. But what happened was the argument was put forward that, well, yes, there was a policy that said you might look at my email, and yes, you might review it and back it up and store copies of it, and yes, I understand that by using the computer I let you do that, but you never told me in the policy that you might use this against me in court. And that was the argument that struck quite true with the judge. Interestingly, that matter settled, so we never got a ruling on how that particular argument would have flown, but if you're going to run in court and you come across that issue, then there will definitely be lawyers who will be willing to run it for you. Sorry, I think we've got time for another one.
We certainly have time for another question. Was there a hand up over there?
Third question.
Oh, mate, you already had two.
Pay extra.
We should get rivals to ask a question, mate. No? Yeah. Yeah. It's a really good question.
Nick, have you ever been in a situation where the organisation has actually orchestrated the events in order to make an employee perform a particular act, as such as the one that you've actually, the email incident?
Perform, what do you mean?
In other words,
frame someone?
Sorry?
As in framed someone?
Not actually frame, but to actually coerce the person into sending particular emails outside the organisation to, basically.
Oh, so whether an organisation gets someone to do something and then uses it against them?
Correct.
No. I've come close. I've had situations where people, I've done cases where people have been framed for things. And, when the computer evidence was examined on face value, it looked like the person did it. But then when we did some more deeper analysis, we actually found that the same evidence disproved that the person had done that at all. And in fact, when we analysed it further, we found, various VNC connections going into the person's computer and creating the activity that they were alleged to have done. So you get things like that. You get people manipulating evidence. You get, court cases where you get documents that are presented where they've been fabricated, and when we go in and analyse them, we show that they're fraud. I did a case where I was given a paper copy of an email, and that's all we had. And by analysing the headers on the email, we could conclude that the email was basically a fake, because when we compared the way the email was presented with the story that the person gave about how that email came to be, we said, no, this is garbage. It just could not have happened like that. So you do get sort of that manipulation, but I've never had that one.
We've got time for one more really quick question. Your question, mate? Sure you do. Couldn't show you up before. Yeah, all right. Well, if that's no more questions, guys, you're going to walk all the way down there, aren't you? So you mean you guys don't just run Encase and just make a PDF of the report that comes out?
Yeah, absolutely. A few years ago, there was a story put on I think it was a Cyberspeak podcast, where a couple of prominent forensic people announced that there was a tool that they were developing called Forensicator Pro, and it would take all of the work out of forensics. Basically, you pointed an image, press the button, and it would create this report. And now they released that story on the 1st of April that year, which should have been a clue as to what they were talking about. But apparently they still get emails from people saying, where can I download my copy of Forensicator Pro? It sounds great. So we often joke about the find evidence button. And I often say it's next to the button that says print invoice. Anyway.
That's fantastic. We have one more question back here.
Oh, hi, Nick. How do you analyze data that has been through different time zones?
Yeah, it's a really tricky one. I did a criminal case with Mr. Daniel a few years ago where we had exactly that. We had someone who, we were doing the prosecution, I should add, and there were some very serious criminal offences, and this person travelled a lot. And really, really, really key to their defence were arguments about where the person was at certain dates and times. And there were issues such as, we would get an email, we'd have two copies of an email, one would have a certain timestamp, the other would have a differing timestamp. So the other argument that they raised was, well, your evidence is all inconsistent, we can't trust any of it. And we had to actually analyse what was happening in the email headers and then figure out which email server was stamping it with which timestamp, and then go into things like index.dat, like internet history and file access records, and show how timestamps changed. And there was one classic piece of evidence that we put together where there was a particular document, there was a time when this person got on a plane overseas and travelled to Australia, and there was certain activity that he performed while he was actually on the plane. And by reconstructing time zone information and figuring out the accuracy of timestamps, we showed that this activity could only have happened on that computer when the person was sitting in their seat on the plane, which was really critical because a lot of the defence was based on, it wasn't me, it was someone else. So we had this point in time where we said, well, unless it was the trolley dolly, it was you. So yeah, you get that, and it's tricky. Time is hard. As a general sort of closing remark, analysing time, there are so many variables, it's difficult, but if you can make it work, it's incredibly powerful.
Ladies and gentlemen, Nick Klein.